Alright, so welcome to Noble Team YouTube channel for today, and we want to look into elasticity. Now this particular topic is a vital topic that any student preparing to write WAEC, NECO, JAMB must know, because questions normally comes out from this particular topic, and I need you to pay maximum attention in this particular video section of today. So now this is the class content of what we do be looking. What is elasticity, Hooke's law, tensile stress and strain, young modulus of elasticity, JAMB point, bulk and shear modulus. Some of you might be coming across, some of you might be coming across this for your first time. Just relax, I'm going to be explaining it. Work done in elastic material. 24 solid exam questions on elasticity. Now these 24 solid questions will be cutting across JAMB, WAEC and NECO for people that are preparing to write any of these exams. And we are going to be solving 24 solid questions, and I will implore you to follow this video to the end. And if you are new to this channel, my name is Noble, CEO and founder of Noble Team. And if you have not watched the previous video that we normally post, and I will implore you to do what, to go back or share the description of this video to watch the previous video that we have done so far. Now before we dive into the tasks we have for today, I will advise you to get a biro, a book and a calculator, and also if you have earphone, headset or earpod to limit any distraction. Now without wasting up much of our time, let's look into what is elasticity. Now I want you to take note that this particular note will be appearing on your screen. All I want from you is to be writing down in your notes. Now what is elasticity? Elasticity is the ability of a material to return to its original shape and size after being distorted by an external force. I hope you get it. Now let me explain what this particular point is all about. Now take for instance a rubber band. Like once you get a rubber band, you just leave it in its normal position. But once you stretch that particular band, do you understand? Once you use your two hands to stretch it, and at a point you removed your second hand from it, you notice that it will return to its normal position. So that is what they mean by elasticity. Now the next one is, what is Hooke's law? Now let me tell you, let me be honest with you. If you are a candidate watching this video, I will advise you to know Hooke's law, because in 2023 when I took my WAEC, they asked what is Hooke's law, and I know Hooke's law when I was in SS1, because this particular Hooke's law is a topic that you must do in SS1 before you start entering SS2 SS3. So what is this Hooke's law? Hooke's law states that the extension of any elastic material is directly proportional to the applied force or load or weight, provided that the elastic limit is not exceeded. Provided that the elastic limit is not exceeded. Let me state it again. Hooke's law states that the extension of any elastic material is directly proportional to the applied force or load or weight, provided that the elastic limit is not exceeded. Now let's take this particular thing mathematically. Let's state it mathematically. Excuse me, let me just open this. Now stating this particular thing mathematically, this is what they mean. When F is directly proportional to what? E, which is the extension. Now removing this sign of proportionality, I will have something of F is now equal to K E. Now what is this F? What is K? What is E? Now F is what? Force. F is force. Then K is what? Force constant, or we call it K is force constant, or we call it elastic constant. Force constant or elastic constant, or we can also call it the stiffness constant. I want you to take note that force constant and constant force are not the same thing. Do you understand? Force constant and constant force are not the same thing. Now once we talk about force constant, you are talking about K. Once you talk about constant force, you are talking about the normal F. Force constant K, normal constant force, you are talking about the normal F force. Now E is the elasticity. E is the elasticity, which is what? The extension. Do you understand? And this elasticity is always measured in meter. Elasticity is always measured in what? In meter. So I hope you have written down this point. Now the next one is, I want you to take note that this particular thing can also be written as, when we have F over F1 over E1 is now equal to F2 over E2. Now, when can I use this particular formula? When I have two forces. Imagine I have two forces and I also have one extension. Do you understand? I also have one extension. So, and I'm also asked to get the second extension. So I'm going to be using this particular formula to solve. Do you understand? Yes. So now take note of these particular two formulas. I said that the normal F is called the constant force. Then the K is called the force constant, elastic constant, or stiffness constant of the material. So I have also listed the formula that you need to take note. Now the next one is the tensile stress and strain. Tensile stress and strain. I hope I mentioned the what are they calling it? The unit of this. When I say that extension is always in meter, this is always in Newton meter. Do you know why I say this is always in Newton per meter? Wait, let me just derive it so you can understand fully better of what I'm trying to say. It's not when we start solving questions you'll be making a lot of mistake. Now, I want to get the unit of K, which is the constant. What am I going to do? This is very, very simple. Follow me. Making this the subject of formula, I have K is now equal to F over E. Now, what is the unit of force? Newton. What is the unit of extension? Meter. Then I have K is now equal to Newton per meter. Or you can write it as Newton meter hyphen 1. Do you understand? Yes. So when we start solving questions, don't just get it that it's something that we are doing magic here. We are not doing magic. Do you understand? Now the next one is tensile stress and strain. Now tensile stress is the ratio of force acting on a unit cross-sectional area of an elastic material. Now I want you to get something here. Cross-sectional area and normal area are not the same thing. If you are writing something of WAEC or NECO and even JAMB, do you understand? They might just give you a trick. Okay, they will just define it and give you the option. Which one is this? Is it tensile stress or is it strain or whatsoever? You can pick it without listing cross-sectional area. Cross-sectional area is a key point in definition of tensile strength. So now you say that is the ratio of force to area. It is the ratio of force to area, which is what? X. I have XT. Let me just XT is now equal to force over area. Now, do stress have a unit? Yes. Its unit is this. When we have Newton and area is what? Area is what? I hope you know that area is length times width. Do you understand? Length times width, which is what? Area. Then, and length times width, its unit is what? Meter square. So it is now what? Newton per meter square. And I want you to take note of this. Recall vividly which other quantity have the same unit as Newton per meter square. Okay, it is what? Pressure. Now we can also say that the unit of tensile stress is also what? Pascal. Is also what? Pascal. The unit of tensile stress, can also be Pascal. So I hope you have written down these points. Now we have its formula. I've listed the formula, which is force over area. Now in a question, you might be solving a question and you are asked to get the tensile stress, but you don't have the area. But in the question you have radius. You understand? Now for you to calculate for your area, you have to do area, which is A, is now equal to pi r square. Take down these points, pi r square, because we are going to be solving questions and you will be seeing where to apply all these things. Now the next one is tensile strain. Now tensile strain is the ratio of the extension to the original length, to the what? Original length. Now it says here it does not have a unit. It does not have a unit. Now do you want us to prove that it doesn't have a unit? Yes, I'm going to prove it. Do you understand? Just make sure that you are writing neatly in your notes. Now it says that it is the ratio of extension to the original length. And yes, to the original length. Let me just keep this particular point that I want to mention now, because when we start moving on, I'm going to list the points. Now they say that x, which is the stress, is equal to the extension over the original length. I'm going to use LO. Now what is the unit of extension? Is meter. Then length is what? Meter. Once you cancel out this, do strain have a unit? It doesn't have a unit. This proves that tensile strain is a dimensionless quantity. Take down this point. Tensile strain is a dimensionless quantity. Now once you talk about anything that is dimensionless, just know that it doesn't have any unit. Anything that doesn't have unit is dimensionless. This is very, very simple. Just take down that particular point. I've listed out the formula, and remember there is difference between original length and extension. Now let me explain original length and extension. Now once you talk about original length, it simply means, for example, you have this type of question that in a rubber band, you have a rubber band, you measure the length, and its length was 10 cm. Do you understand? Its length was 10 cm, and at a point you stretch that particular band, it moves from 10 cm to 15 cm. So its original length is what? 10. Do you understand? The one that you extended is what? 15. For you to be able to get your extension, you are going to do 15 subtract from 10. You get your real extension, which is 5. That was what? Extended. Do you understand? Now the next one is Young modulus of elasticity. Young modulus of elasticity. Now Young modulus of elasticity is the ratio of tensile stress to tensile strain within the elastic region. So it's still talking about that Young modulus is the ratio of what? Stress to strain. Now let me write out the formula. Imagine you have a Young modulus being represented with Y, which is what? Stress over strain. Now you want to get the unit. The unit of this is what? Newton per meter square. This is what? Dimensionless. So I'll just put 1. And once you are done, you have its units to be Newton per meter square. Now what do you observe here? That the unit of Young modulus is also the same thing to tensile stress. Do you understand? It's also the same thing to what? Tensile stress. Do you understand now? Now moving on, I've given you the formula. This is the formula to calculate for it. Now I want you to take note of something that is very, very important, because when we start solving questions, that is what I'm going to be using. Normal ST is called what? The stress. Now normal X, without writing anything, is strain. So why I listed it out is when we start solving questions, you will not get confused of what we are doing. Now the next one is JAMB bullet points you need to take note of. Now tensile stress and Young modulus have the same unit. I've mentioned it. And dimension as pressure. Yes, and dimension as pressure. Now I want you to take note that any quantity that have the same unit also have the same dimension. Any quantity that have the same unit also have the same dimension. Now tensile strain has no unit. Young modulus depends only on the type of material from which an elastic wire is made. From which an elastic wire is made. Now the next one is bulk and shear modulus. Now this particular bulk and shear modulus is something that you will encounter when you are in 100 level. But why I listed it out is for you to just know it in case you see it in your JAMB exam. Because I've not seen anywhere they asked it, but I'm going to explain it. Now, bulk modulus. Bulk modulus tells how hard it is to compress a material. It tells us how hard to compress a material. And its formula is what? When we have K is equal to change in pressure divided by what? Fractional decrease in volume. Fractional decrease in volume. This is the formula for what? Bulk modulus. Fractional decrease in volume. Now, key point that you need to take note here. Measures resistance to compression. High bulk modulus, it will also have a material that is less compressible. Now, take note that the unit of this particular bulk modulus is what? Newton per meter square or Pascal. Newton per meter square or Pascal. Now, the next one is the shear modulus. Now, shear modulus can also be called the rigidity modulus. Shear modulus can also be called the rigidity modulus. Rigidity modulus can also be called what? The rigidity modulus. Now it tells us how hard it is to change the shape of a material by shearing. You can see that the other one is telling us how hard to compress, which is bulk. But shear modulus is telling us how hard it is to change the shape of a material. So now, the symbol for shear modulus is represented with what? G. Now, the next one is, its formula is shear stress over shear strain, which is also the same thing with the Young modulus. Do you understand? And it also has the same units. It also has the same units with Young modulus. Now, once you hear modulus, anything modulus have the same units with all of them. Do you understand? Now, let's look into the next one, which is work done in elastic material. Work done in elastic material. Now, work done on an elastic material is given by what? Now, I want you to take note that the work done in elastic material have three formulas. And I will implore you to take down that particular three formulas. Very, very important. Write it down in your notes, because we are going to be making use of it to solve question. Now, number one, when we have W, which is the work done, half Fe. You have the next one, W half Ke square. We have the next one, W F square over 2K. Now I'm going to explain all these things. Now, pay maximum attention here. Now, work done is equal to half Fe square. Now, how can I know when to use this formula? This is very, very simple, and this is the trick I normally use. Now, once you hear elasticity, do you understand? Once you hear elasticity, extension, just record that you are using this formula. Do you understand? Sorry. Once you hear force constant, do you understand? Once you hear force constant, you can see that force constant is not available here. You just know that you are using this. Now, once you hear that force constant is not available, that you are wearing constant force, you are making use of this. Now, when you have constant force and force constant, you are going to be making use of this formula. Now, we are done with this note. The next thing is for us to solve questions. And I implore you to master these formulas very well that we are listed, Now let's solve important, should I call it important for questions? Let's solve 24 solid exam questions. Now let's start with solving number 1. Now let's solve questions on what we have done. Now we are going to be starting with question 1, and get your calculator. Number 1 says calculate the work done when a force of 20 Newton stretches a spring of 50 millimeter. Stretches a spring of what? 50 millimeter. Now question 1. We are going to call it question 1. Now calculate the work done when a force. Now which formula are we going to use? Because we have here force. We are going to be making use of when W is equal to half Fe. Right? This is the formula that we are going to be using to solve. Now they say that the force is what? 20 Newton. So you have 1/2 multiplied by 20 multiplied by, now it says that stretches, which is it's extended towards 50 millimeter. Now are we going to be using this 50 millimeter? No, because the unit of extension is in meter. So converting that 50 millimeter to meter, which is 50 divided by 1000. So I'm going to be having 0.05. This is what I'm going to be having. Now let's multiply. Let me get my calculator. Alright, now let's multiply. I have, make sure that you are doing your own. Multiply by 20. Alright, so we have it to be equal to 2.0 joule. I hope you know that the unit of work done is in joule. Now let's look into this question to know which option is correct. We have it to be option B is correct. Now let's solve question 2. Let's solve question 2. Make sure that you are writing. Now question 2 says a force of 500 Newton is applied to a steel wire of cross-sectional area 0.2 meter square. Then the tensile stress is what? So we are asked to get the tensile stress. Then we have question 2. Tensile stress is what? ST is A is force over area. Now our force here is what? 500. Then our area here is what? 0.2. Then let's divide. We have it to be what? 22,500. Now looking at this option, it is in standard form. We need to convert it to standard form. Now this is how to convert to standard form. I want to move it because this is where it ends. 1, 2, 3. So it is what? 2.5 times 10 raised to power what? 3. Now let me just give you a quick trick. Now once you are moving backward, it should be what? Positive. When you are moving forward, it should be what? Negative. Now this particular option, option B, is correct. 2.5 times 10 raised to power times 10 raised to power Newton per meter square, because we looked for the stress. Yes, for the stress. So this is the unit of what? Of it. Question 3. The tendon in a man's leg is 0.01 meter long. If a force of 5 Newton stretches the tendon by 2.0 times 10 raised to power minus 5 meter, calculate the strain on the muscle. Now these people want to confuse us by adding force. Now we all know that the formula for strain is extension of volitional length. Now coming to this, how can we know our extension? Excuse me. Our extension is where you stretches. Now stretches, if a force of 5 Newton stretches the tendon by 2 points. So it simply means S is now equal to 2.0 times 10 raised to power minus 5. Then the next one is the original length. The original length is 0.01. Now we want to convert it to standard form. It is going to be 1.0 times 10 raised to power minus 2. Now let's divide. 2 divided by this. We also have what? 2. Then we have 2.0 times 10 raised to power. Now, whenever, this is very simple. Whenever you have a division sign, what comes to your mind when the powers are different? You subtract. This is a basic rule in indices. If you don't know indices, the indices that I'm talking about is not the deeper one. Just know the first 4 rules. The multiplication, the power rule, and so on. Now, coming to this, you subtract. Minus 5 minus 2. You have raised to power minus 3. Do strain have units? No. Now, let's look into this question to know which option is correct. Option C is correct. And looking at the option, it doesn't have units, so they are unitless. Now, the next one is question 4. A string of length 4 meters is extended by 0.02 meter when a load of 0.4 kg is suspended at its end. What will be the length of the string when the applied force is 15 Newton? Now we are asked to take G, which is 10 meters per second. Now we are going to take this particular thing very well. Now let's read the question. It says a string of length. We are asked to get what will be the length of the string when the applied force is 15 Newton. Now, the first question, let's read the question again. Sorry. Is a string of length, which is 4 meters, is extended by 0.02 meter when a load of 0.4 kg is suspended at its end. What will be the length of the string what will be the length of the string when the applied force is 15 Newton? Now, listen, let's solve together. It's very simple. The first thing that we are going to do here is to get the first force. Yes, to get the first force. The second force, I think, yes, the second force. Now, solving for this, we are asked to take gravity as 10 meters per second. Now, which is force can be weight, or we can call it force, can be mg. Do you understand? Now we have F is now equal to our mass is what? 0.4 multiplied by 10. Do you understand? Now 0.4 multiplied by 10, we have it to be what? 4 Newton. 4 Newton. So now they said a string of length is extended to. So it simply means that the 4 meter is just the original length. Do you understand? And the original length is not the same thing with the extension. So when you hear extension, it's something that was extended. They are not talking about the original length. So we are going to be making use of this formula that says, remember when I said that F over this, F1 this, over F2 over E2. This is what we are going to be using. Now, our first force for what we have solved is 4 divided by. Now, what is going to be our extension? 0.02 meter. Why? Because this was something that was extended. Do you understand? We are not going to be making use of 4 because it wasn't extended. Now, is equal to, second force is what? 15 divided by what? The unknown. Now follow me closely. E is now equal to, or let me make use of it, this place. This will cross multiply. We have 15 multiplied by 0.02 divided by 4. Now let's solve. 15 multiplied by 0.02 divided by 4. We have it to be 0.075. 0.075. Now we are asked to get what will be the length of the string when the applied force is 15 Newton. Now you are going to add it plus 4. You are going to what? Add it what? Plus 4. Do you understand what we did here? We have gotten the normal length. Do you understand? We have gotten the extension of this that was exceeded. It simply means that it was exceeded to 0.075. That was something that was exceeded from this particular point to this. Do you understand? Now, the next thing we ask to get, what will it be when the force, when the force that was applied to it is 15 Newton? Remember that we have the original length that was 4. Then to get the total length, we now have T is now equal to 4 plus 0.075. Now if you add this up, you have it to be what? 4.075, approximately 4.08 meter. So option D is correct. Now let's solve more questions. You understand? So for you to have a better understanding of this particular thing, always read the question very, very well. You understand? Because English is something that kills many students, and you need, even me. Do you understand? Because some of us will just rush into questions and you would think that you already know it. Do you understand? Just read the questions very, very well and you understand the grammar there. Now, question 5. If a load of mass is 10 Newton, stretches a cord 1.2 cm, what is the total work done? What is the total work done? Now this is question 5. What is the total work done? Now coming to this question, we are going to be making use of, we are asked to get the work done, which is half Fe. Now 1/2, then our force here is what? 10 multiplied by, now our extension is 1.2. You convert it to meter, which is 1.2 divided by 100. You have 0.012. Now multiply this up. If you multiply this up, you have 0.06. You have 0.06, which is 0.06. Now looking at the option, is our option in decimal form or in standard form? It is in standard form. We need to convert it back to standard form. Now converting it back to standard form, this is 1, 2. So it's going to be 6.0 times 10 raised to power minus 2 joule. This is the final answer. Now it simply means that option C is correct. Option C is what? Correct. Now the next one is question 5. Now this particular question 5, pay maximum attention. Question 5 says the diagram above represents, is it question 6? The diagram above represents the graph of the force applied in stretching a spiral spring against the corresponding extension. The force constant of the spring is what? Now once you hear force constant, they are talking about the elastic constant, which is K is equal to F/E. Now what is the next step? Now look at that graph. It's something like looking for the slope of this graph. Do you understand? Which is 120 minus 40 divided by, you have what again? 6 minus 0. 6 minus 2, sorry. Yes, 6 minus 2. So you have 120 minus 40 is 80 divided by 4. 80 divided by 4, you have 20. Now what is the unit of this force constant? Newton per meter, not Newton per meter square, Newton per meter. Now option C is correct, Newton per meter. Do you understand? Now the next one is question 7. You can see that we have solved up to 1 to 7 now, and you can see that we are progressing. So make sure that you know all what we are doing now, because these particular things are core JAMB questions, core WAEC questions, core NECO questions that you yourself will see in your exam, and you will feel normally that you know it. Do you understand? And I will give you 100% assurance that you can solve it. Do you understand? Now let's solve question 7. Question 7: determine the energy stored in an elastic material whose force constant is 1.2 times 10 raised to power 5 and extend by 2.0 cm. Now I want you to take note of this, as in this elasticity, in linear expansivity, in modern physics, yes, if you don't know how to convert to standard form, I don't think that you can be able to solve any problem, any questions on that particular topic. Or in fact, any question in physics, you must know how to convert to standard form, because this is where students fail woefully on it. Do you understand? Now, this question 7, we are asked to get question 7. We are asked to get the energy stored, and in this particular thing, we have force constant. So it simply means that we are going to be using W is now equal to half K E square. Do you understand? This is the formula that we'll be using to solve. So we have 1 over 2 multiplied by our force constant is what? Excuse me. Our force constant is 1.2 times 10 raised to power 5. 1.2 times 10 raised to power 5 multiplied by, now our extension is in cm. Now converting it to meter, we have it to be what? 0.02. Now 0.02 squared is what? Is 4 times 10 raised to power minus 4. Now the next thing that we are going to do is this multiplied by this. When we have 4 multiplied by 1.2, then we have 2.4 times 10, yes, 2.4 times 10 raised to power 5 plus minus 4. 5 plus minus 4, you have 1. Now looking at this question, if you look at the option, you will see that it is not in standard form, it is in whole number. So we are going to convert this to whole number. What am I going to do? Remember, this is 2.4. So it is going to be, when this particular decimal moves here, then I'll have 4.0. Do you understand? I want to remove this decimal that is here. Is where once it moves here, I will now have 24.0. 24.0 what? Joule. Do you understand what I did here? So this is the final answer to question 7. This is the final answer to question 7. So option A is correct. Now the next one is question 8. I'm going to be making use of here to solve. Question 8. So I'm going to be making use of this particular side to solve. Once it gets filled, we wipe up the board and we continue solving. Now question 8. A spring of force constant is 500 Newton per meter is compressed such that its length shortens by 5 cm. The energy stored in the spring is what? We are also going to be making use of this particular the same formula. Now we now have W is now equal to 1 over 2 multiplied by 500 multiplied by, then we convert this 5 cm. We convert this 5 cm to meter. Converting this 5 cm to meter, it is 0.05. Then 0.05 raised to power 2 is 0.0025. Now let's add this up and get our final answer, where we have W is equal to 500 multiplied by 0.0025. So we have it to be 0.625. 0.625 joule. So option C is correct. 9. A copper wire was subjected to a tensile stress of 7.7 times 10 exponent 7. Calculate the tensile strain of the wire if the Young modulus is 1.1 times 10 raised to power times 10 raised to power 11, or you call it exponent 11. Now question 9. So we have question 9 and we are asked to calculate for the strain. Remember that Young modulus Y is equal to stress over S. Now making the subject of formula, and I have X is now equal to XT, which is stress over what? Y. Now our stress here, our stress is 7.7 times 10 exponent 10 exponent 7. 7.7 times 10 exponent 7 divided by our Young modulus is 1.1 times 10 exponent 11. 1.1 times 10 exponent 11. Now let's divide. When we have Y is now equal to 7.7 divided by 1.1. I have it to be 7.0 times 10 raised to power 7 minus 11. 7 minus 11 is what? Minus 3. So Young modulus is what? Newton per meter square. Is it? No, not Young modulus. Stress and strain. So it doesn't have units. You understand? So this is the final answer for what? For the value of strain. So it simply means that option C is correct. No, not option C. Option A is correct. 7.0 times 10 exponent minus 3. You can see how they want to confuse someone. They even wrote exponent minus 4. So option A is correct. Now the next one is 10. So take note that strain doesn't have units. Question 10. Make sure that you are writing. Make sure that you are writing. Now question 10 says if a load of 1 kg stretches a cord by 1.2 cm, what is the force constant? What is the force constant? What is the force constant? Now in this question, what are we asked to get? What are we asked to get? Force constant. Now once you hear force constant, they are talking about force to get K. So let's just write this formula out. F is equal to what? Ke. Now do we have force? We don't have force, but we have we have our mass, which is the load. Now remember that in physics, when you are solving for any question in physics and you are not giving G in question, you use 10 meter per second square. But when 9.8 is given to you, you make use of it. Do you understand? Now looking at this, we want to get our force. For us to be able to solve for our force, which is F is equal to what? mg. That is why I have 1 multiplied by 10, which is what? 10 Newton. So we have written our force. Now making our force constant subject of formula, I have 10 divided by. Now 1.2, we need to convert it. We have to 0.012. We now have 10 divided by 0.012. We have it to be 833.3 Newton per meter. So this is our what? Force constant. So it simply means that option C is correct. Now you can see that we have solved 10 questions now, and this is what I will employ you to do. The next question that we'll be solving, I want to know if you are understanding it, and also you want to know if you yourself understand what we have done from question 1 to 10. Once I read out the question, you will pause it, solve. Then after solving, you will now press the video and know if you are correct or not. Do you understand? Now let's solve question 11. The next one is question 11. A force of 15 Newton stretches to a spring to a total length of 30 cm. An additional force of 10 Newton stretches the spring to 5 cm further. Find the natural length of the spring. Now read this question very well. Read it very careful. Now the first one is, the first force is what? 15. And we have it to be what? 30 minus 11. Now the second force, it says that an additional force was added to this, which is 10 plus 15. An additional force of 10 Newton stretches the spring further, stretches the spring 5 cm further, which is what? 10 plus 15, 25, divided by. Now the next one is, remember, additional. Then you now add 5 to this 30, because 30 was the original one, but an additional length was added to it. You now have 35 minus L. Now the next step, you cross multiply. Once you cross multiply, you have 15 into brackets 35 minus L divided by 30. No, it's not divided by. Is equal to 25 into brackets 30 minus L. So it's not divided by, because we have not opened this bracket. It's when we open this bracket, collect like terms, we will now divide. Now this will multiply everything here. Now 15 multiplied by 35. 15 multiplied by 35 is 525 minus 15L. Then 25 multiplied by 30. You have it to be 750 minus 25L. Now let's collect like terms. You now have, if you collect like terms, you have 750 minus 525 is now equal to minus 25 plus 15L. So 750 minus 525 is 225. 225, and this particular thing, minus 25 plus 15L is 10L. Then L is now equal to 225 divided by 10. 225 divided by 10 is 225 divided by 10, 22.5 meter. So it simply means that the original length of this particular question is 22.5 meter. Now let's look into the question to know which option is correct. So option D is correct, which is centimeter. Now, do you know why we use, do you know why the question option is in centimeter? Because we didn't do what? We didn't convert. Do you understand? We didn't convert it. Because eventually if we converted it, we are not going to be getting our answer in CM. Now, let me give you a trick. When you are solving question, the first thing that will get into your mind is go through the option first. Know the units that is present here. Do you understand? Because the first thing that you are going to do, imagine that after solving that you are asked to get the extension, and in your question, or in your option rather, it is in centimeter. So it simply means that something that you are solving, and if you are given in centimeter, you don't need to convert it since the option is in centimeter. I hope it's clear. Now the next one is question 12. A stone of mass 5 grams is projected with a rubber catapult. If the catapult is stretched through a distance of 7 cm by an average force of 70 Newton. Calculate the speed of the stone at the time of release. Now this is question 12. Now in this question, we are going to be using this formula. Looking at this question, do we have force constant? No. So we are going to be using Fe is equal to half mv square. This is the formula we are going to be using. Now, if you can remember, you can recall vividly, this is the formula for what? Kinetic energy. Kinetic energy. Now, this particular thing, we cancel out this. We are now left with this and this. Now, let's fill in the parameters. Our force is in what? Coming to this, do we have our force? Yes, we have our force to be 70 Newton. Multiplied by our extension is in cm. Now, looking at this option, you can see that the option is in standard SI units, or we call it, yes, the SI units, standard international unit, sorry, which is the SI unit. So it simply means that we are going to be converting this particular centimeter to meter. Do you understand? Because this particular SI unit is first thing that you are going to do, like it's first thing that you are going to see when you open any physics textbook. Now, converting this 7 to meter, it is 0.07. It's now equal to, our mass is in gram. Is it supposed to be in gram? No, it is supposed to be in kilogram. Now we now have 5 divided by 1000. You have 0.005 v squared, because we are looking for the speed, the velocity of it. So we have 70 multiplied by 0.07, 4.9 is equal to 0.005 v squared. Therefore, you have v squared is equal to 4.9 divided by 0.005. You have it to be what? 980. V squared is now equal to 980. Now, removing this, we are going to be adding V is now equal to the square root of 980. Square root of 980 is what? Square root of 980. We now have V is equal to 31.3 meter per second. So this is the what? Final answer. So it simply means that option A is correct. 31.3 meter per second. So you can see they want to confuse us by using 3.13 meter per second. So you should be very, very careful of what you are doing when selecting questions. It's not when you waste your time, solve and get the final answer. At the end of the day, you will pick the wrong one due to your what? Your fastness. Now the next one is question 13. Question 13. Question 13 says an elastic material has length of 36 cm when a load of 40 Newton is hung on it, and a length of 45 cm when a load of 60 cm is hung on it. Then the original length of the string is what? Excuse me. So when I see this question, I laughed because it's very, very simple, despite the grammar that is here. So an elastic material has a length of 36 cm when a load of 40 Newton is being hung on it, and also we have a length of 45 when a load of 60 Newton is hung on it. Then the original length of the spring is what? So you are going to be using this particular method that we use in question 11. Now looking at this, we have 40 divided by 36 L minus L is now equal to 60 divided by 45 minus L. This is what we are going to be doing. Having. Do you understand? Now you cross multiply. If you cross multiply, you have 40 into bracket 45 minus L is now equal to 60 into bracket 36 minus L. Then let's multiply. 40 times 45. You have 180. No, 1,800. 1,800. If I'm not doing that particular mistake. 1,800. Yes. Minus 40L. 60 multiplied by 36. 2,160. Minus 60L. The next thing, you collect like terms. You collect like terms. Now let's collect like terms. You have it to be 2,160 minus 1,800 is now equal to minus 60L plus 40L. Let's punch our calculator. I have 360 here. I have it to be 20. Then 360 divided by 20. 360 divided by 20 is what? L is now equal to 18 cm. So it simply means that 18 cm is correct, which is what? Option D. Did we convert here when we are using the centimeter for the extension? No, because since our question is leading us to a centimeter, so you don't need to convert. Do you understand? Now the next one is question 14. So I need to wipe up the board so we can have enough space to solve more questions.
14. Now question 14 says a spring of force constant is 1,500 Newton per meter is acted upon by a constant force of 75 Newton. Calculate the potential energy in the string. You can differentiate between force constant and constant force. I hope you can do that because I've explained it. Now looking at this, which particular formula are we going to be using? We are going to be using this formula where we have, you know that energy and work have the same units. So we have E is equal to X squared over 2K. Right? You can remember this formula. Now our constant force is 75 multiplied by 75 divided by 2 multiplied by 1,500. Right? 1,500. Now let's subtract. Let's multiply. Sorry, we have 75 multiplied by 75 is E is equal to 5625 divided by 2 multiplied by 1,500 is 3,000. Then divide 5625 divided by 3,000. I have it to be what? 1.875 joule. So this is our final answer. Let's look into the question to know which option is correct. So option D is correct. They approximated this to what? 1.9 joule. So now the next one is question 15. And if you're enjoying this video and you have not yet subscribed to our YouTube channel, do what to subscribe to it, like this video, comment, share it to your friends out there so they can benefit. Now question 15. A load of 20 Newton on a wire of cross-sectional area 8 times 10 exponent minus 7 produces an extension of 10 meters square. Calculate Young modulus for the material of the wire if its length is 3 meters. Now Young modulus is stress over strain. Now let's calculate for stress. Stress is what? 20 divided by 8 times 10 raised to power minus 7. So you have 20 divided by 8. I think 2.5. Let me just check. Yes, I'm correct. 2.5 times 10 exponent minus 7. Then our string is extension, which is 10. 10 divided by 3. Right? No. Alright. Is it 10 that we have here? Because they wrote 10 meters squared. Is it going to be in meter squared or in normal meter? It is going to be in meter. So that squared there, it simply means that they have squared m. This is what they have. Do you understand? So this is what they have. Now, how am I going to write this? So writing 10 raised to power 2 is something of writing 0.01. Yes, it's something of writing 0.01 divided by 3. So 0.01 divided by 3. I have 3.3 times 10 raised to power exponent minus 3. So your modulus is now equal to 2.5 times 10 exponent minus 7 divided by 3.3 times 10 raised to power exponent minus 3. So 2.5 divided by 10. 2.5 divided by 3.3. I'll have it to be 0.75. So 0.75, right, times 10 exponents minus 7 minus 3. I have it to be minus 4 raised to power minus 4. Now, are we going to leave it like this since our option is not in decimal form? Right? It's not in 0 points. Do you understand? So what am I going to do? I'm going to convert this. Then converting 0.75 is something of saying 7.5 times 10 raised to power minus 1. Right? Then this particular 4 plus into bracket minus 4. I have 1 minus 1 plus minus 4. I have it to be minus 4 plus minus 1 plus minus 4. I have it to be minus 5. So it's going to be what? 7.5 times 10 raised to power exponent minus 5. So looking at this option, which option is correct? Because according to option C, it says 7.5 times 10 exponent 11. So it simply means that we are going with what? Option 16. If the stress on a wire is 10 exponent 7 and the wire is stretched from its original length of 10 centimeter to 10.05 centimeter, the Young modulus of the wire is what? So we already have the stress, but we don't have the strain. Now it is going to be 10.05 minus 10.00 divided by 10. You have 0.05 divided by 10. Then your x, 0.05 divided by 10. You have 5 times 10 raised to power minus 3. This is what you are going to have. Then you have Young modulus is now equal to 10 exponent 7 divided by 5 times 10 exponent minus 3. Then this into this is 2 times 10 exponent minus, this is going to be exponent minus 9. Exponent minus 9. So this is the final answer. Let's look into the option to know which option is correct. So option B is correct. This is not minus 9. So option B is correct. Now let's solve question 17. So I'm going to be solving 20 questions and I'll give you 4 as an assignment. So you will solve it and it will be in the comment box. Question 17.
My name is Miracle and I scored 313 in the 2025 UTME examination with the help of Noble Team 9 classes. Oh my god, the class has been amazing. I did math, physics, chemistry and English, and the lectures was top notch. Like, I can't believe I could score 98 over 100 in math. Like, Noble Team made my dream come true, you know, with the help of our mentors. You know, they didn't give up on us. You know, their teaching was just outstanding. You know, Noble Team made my dream come true. I just thank Noble Team because it made an impossible dream, which seemed impossible at first, you know, to become a reality. Thank you, Noble Team.
Question 17 says, if the stress on a wire is 10 exponent 7, and I think we have solved this question. Yes, we have solved it. Now let's move into 18. Now question 18. So both of them are the same thing. So let's look into question 18. Question 18 says a spring of length 25 centimeter is exceeded to 30 centimeter by a load of 150 Newton attached to one of its ends. What is the energy stored in the spring? What is the energy stored in a spring? So a spring of length 25 is extended to 30 cm by a load of 150 Newton attached to one end. What is the energy stored in the spring? So E is now equal to, then the length, which was 25, then it was now extended to 30. So it is going to be extension 30 minus 25, which is going to be 5. Then converting this to meter, we have it to be 5 divided by 100. You have it to be 0.05. Then F, which is 150 multiplied by 0.05. Multiplied by 0.05. So it is going to be 150 times 0.05. So it is going to be 3.75 joule. 3.75 joule. So option C is correct. Now the next one is question 19. Question 19 says a catapult used to hold a stone of mass 500 grams is extended by 20 cm with an applied force. If the stone leaves with a velocity of 4 meters per second, the value of F is what? So F is unknown. Multiply by, it says it's been extended. 20 divided by 100 is 0.2. Multiply is equal to, our mass is 500. 500 divided by 1000, converting it to kg, is going to be 0.5. Yes, let me check it. 0.5. 500 divided by 1000, 0.5 multiplied by the velocity, which is what? 40 squared. So it is going to be 0.2F is now equal to 40 times 40 times 0.5 times 0.5, 800. Then F is now equal to 800 divided by 0.2. 0.2 is going to be what? 4000. Now looking at the option, our option is in standard form. Converting this to standard form, we have 4.0123. 4.0 times 10 exponent 3, not minus since you move backward, in joule. So option C is correct. Option C is correct. Now the last question is question 20. Let's solve the last question, which is question 20, and the remaining 4 you are going to give it to me in the comment box, because I will give it to you as an assignment. Now let's solve question 20. It says the load supported by a spring is increased from 50 Newton to 90 Newton. If the force constant for the spring is 2000 Newton, the additional energy stored in the spring due to the increase in load is what? So we are going to be solving it one by one, and I will implore you to follow this particular question carefully. It is not a regular question, so we have it to be question 20. So we are going to be using F is equal to K E. Now, making this E subject of formula, which is our extension, we have it to be E is equal to F over K. Now, our first force, it was 50, then divided by 2000, right? Then the second force, I'll name it B, which is 90 divided by 2000. 50 divided by 2000 is 0.025. Then 90 divided by 2000, I have it to be 0.045. So we have gotten our E. Let's get the energy stored in it. Now the energy stored in it is in A, which is E is equal to half multiplied by 2000 multiplied by E, 0.025 squared. So our final answer is what? You have 0.025 multiplied by 2000 multiplied 2.5. So I have 0.625. Now let's do the same for B. Half 2000 into bracket 0.0545 squared. 0.045 times 0.045 multiplied by 2000. So it is 2.025. Now the next thing that we are asked to, because in the question we are asked to get the energy stored in the spring due to the increase in load. So getting our energy, I'm going to do change in energy is now equal to 2.025 subtracted from 0.624. Then our change in energy is going to be minus 0.625. It's going to be what? 1.4 joule. So this is the final answer. So the correct option is what? Option D, which is what? 1.4 joule. So we have solved 20 solid questions. We have solved 20 solid questions, and I'm going to give you 4 as an assignment, and I will implore you to do what? To take that particular 4 serious. It is going to be in the comment box. So we have come to the end of this video, and if you want to know about Noble Team, you can check the description of this video, or you text the number on your screen. So I still remain Noble, CEO of Noble Team. In the next episode, bye.